Okay, welcome back everybody to my series on how to use OpenAI with the Retro library to make a Sonic the Hedgehog playing AI using the NEAT algorithm. In the last episode, we set up the config file. I kind of went through it point by point with all the things that I was changing. It's extremely complex, so it's hard to go into any great depth about it. I recommend you go to the documentation and you just read the documentation. It's extremely helpful. But now we're going to jump back into our network and we're going to start building our AI. Neat is super handy. It's really pretty straightforward. You set up a config and then you set up a population. So here we're going to set up a population. And we're going to use the config file to set up the default population. That generates a bunch of variables, which it's not very explicit when it states, but basically there's going to be a variable called genomes that gets created when we do that. We're going to use that later. Then all you do is you do a run. The run needs to call a function that actually operates the it like records the fitness and stuff. So we're going to call that eval genomes. Okay. This won't do anything right now because we don't have the eval genomes function set up, so we're gonna have to write that right now. Let's do that up here. Def eval genomes. And as I had mentioned, it the neat.population function generates another function called genomes, which we're going to pull in here along with the config variable that we set up last time. And yeah, so basically the run function here calls this function, which then will iterate through our steps in our environment and record the fitness of each genome, which it will then compare and then do the whole evolving stuff for us. Okay, we're just going to go step by step with this. So first thing, we're going to set the OB, that's our observation variable. That's the image. That's our eventually will become our input into our neural network. Then reset, that will give us the very first image in the from Green Hill Zone Act 1. We're going to set up a action variable, and this will be just a generic sample. Now we need variables for our inputs. We're going to do inx equals int of oops, excuse me. Let's do inx, ny, and ake. Okay. This variable, the env dot, I can't spell, guys, observation space dot shape, is the size of the image created by the emulator. So it's whatever the resolution of the screen is. So we have three things here. We have the X, the Y, and the colors. So the number of colors. But it's going to be basically, I don't know what the resolution is, but it's some resolution. Can we run this? I don't think we can run this yet because we don't have the stuff set up. Let's see what happens. Python tut2. Oh shoot, we had to install OpenCV. What is it called? CV2? Nope. Oh, I think it's called Python. Excuse me. Pip. We'll go with that. Let's see if that works. Yeah, looks like that worked. So it didn't work because obviously we don't have the rest of our population set up. But yeah, this didn't work, but this stuff here did work. So let's comment this out and just do this. No, let's not do that. Let's do this. just so you guys can see what I'm talking about here. There you go. So it's a 224 by 320 by 3. So we take those numbers, divide them by 8. That's what we're going to input into our network. Okay? So good. There we go. Actually, maybe I should work with all this outside of this first, just so we can see what's happening as it goes. We'll move it back into the function in a sec, just so we can print out results. We're now going to divide these numbers by 8. I am not a programmer by trade, so if any of this looks horrific to you, please comment. Tell me how to make it better. You know, make me a better programmer. Okay, so here's the first thing we're going to do that refers to the neat section. We're going to actually set up a variable called net. Okay, so net equals neat.nn dot recurrent. I gotta make sure I spell this right. Network.create. This is going to include genome and config, which are again here, let's do this in here. Turn this back on, tab that forward, and we're going to do a thing where we iterate through all of the genomes that were randomly generated in the population function. So for genome ID, genome in genomes, our network will create a neat network with each genome, okay? Using the config file. So these are just necessary to set up the neat stuff. This network is what we will eventually use to generate our inputs into the emulator, which we will use to move Sonic step by step through the environment. Hopefully this is clear. If it's not, again, please ask questions in the comments. I'm super love this stuff, so I'll help anybody at any time to the best of my abilities. Again, I'm not like a great programmer. I just really think this stuff is awesome. We're going to set up some variables here to track fitness. Fitness is the output from the network, basically how successful the genome was. If you recall from OpenAI, that comes from our reward function. Fitness current equals 0. We're going to count frames for no particular reason, just because we might need it at some point in time. We're going to have a separate counter for another set of variables. We're actually going to track the X position and the max X position, because we're going to use that to figure out if Sonic's at the end of the level and terminate the neural network. There's other ways of doing this, but it's just this one's pretty explicit. And also we're going to set up done to be false right off the bat. Yeah. So that's how you set it up to get the number of networks for the number of genomes in your genome, which was set up based on your config. So if you have 20, I believe we have 20 populations, so we're going to end up with 20 networks. Okay, and it'll go through one by one each time. Now we're going to do another for loop. This is our while not done for loop. So while Sonic is alive, we're going to do some stuff. We're going to do env render, which will, if you remember from our setup video, this will show us the image, the this value. Oh, sorry guys, that's the wind. It scared the crap out of me. What time are we at? We're at 10 minutes. Fuck, man, I'm slow. Okay, so what else can we do here? We will frame plus equal 1. So every loop through the thing will count a thing. We don't have to do it this way. It's just, again, it's very explicit. So now we got to downsize our screenshot to the size that we're going to use for our neural network. We'll do that with OpenCV. OB, which was the environment variable, which we will also reset every time we do the step, if you recall. that's going to be resized to our values IncX and IncY. Okay, we're now going to make it grayscale. The reason we made it grayscale is because we want fewer input variables. Like the smaller you can make the number of input variables, the quicker it can find solutions. It just has to be enough information that it can find the solution you want. There's a real balancing act with these neural networks. This works, so we're going to do this. Yeah, again, we're going to use OpenCV to do this. Whoever wrote OpenCV, by the way, is a hero. All these guys are heroes. The Neat guys, the OpenAI guys. I'm huge fan of open source, guys. Huge fan. So we're going to do cv2.color underscore bgr2 gray. Okay, that's going to convert our thing to grayscale. So yeah, and we need to reshape it so that it fits the neural network. We're going to use NumPy for that. If recall, we imported NumPy as NP. Reshape OB to InX NY. This is necessary for some reason. Now we're going to do kind of a hacky thing, but we need to compress the 2D image into a single array of values. So we're going to do possibly my favorite part of this entire script. For X in OB, for Y in X, img array. We need an array, and we're going to append the Y values. So what this does is this iterates through the X and Y's and just puts the value of each pixel into a list. We should actually probably define this. I guess it's a hack. I don't know how else to do it. It can only take like 1D input, so you kind of got to do it. But this means that the neural network's looking at a flat line of pixels instead of a 2D array of pixels. Well, I don't know. If anyone knows how to fix that, you let me know. If it was Keras or TensorFlow, we would use a convolution neural network to do this, which I will show you in a future episode if you guys want to see. Okay, so now, how much time do we have left? Fuck, I gotta run. We're going to get the neural network output from the networks that we set up here. So this net, we're now going to activate the network with the inputs that we just found, which will be our image array. Okay, this is basically going to send our inputs through our neural network, and n output is going to be the result of our inputs through our network. This is the whole meat right here. These two functions are everything. So here we go. We do net.activate on the input. And that's it. Now the output of this, print and then output, should be a list of 12 outputs. Let's see if this works. And it crashed. But you'll see right here, these are probably 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 11, 12. Yeah. Counted backwards. There you go, guys. That's how you do it. So over time, the network will train itself to make some of these 0 and some of these 1 based on our fitness. We will finish this in the next episode. Later, guys.